Many real-world situations can be modeled by exponential functions that describe how a quantity grows or decays over time. Some examples of this include studies of populations, bacteria, heat transfer, radioactive substances, drug concentrations, financial accounts, and the list goes on. The exponential function s of t equals 650,000 times 1.09 to the t approximates the average annual salary of a Major League Baseball player, where t is the number of years after 1990. So let's use this function to determine the average annual salary for 2030, assuming that current trend continues. And just kind of a note that when word problems involve time, we'll often use the letter t instead of x. But they both basically mean the same thing. Anyway, 2030, this is t is the number of years after 1990. So 2030 minus 1990 is 40. So that's going to be the value we're going to use for t. And so we're going to look for 40 years after 1990 would be 650,000 times 1.09 to the 40th. So this is something that you would want to use with a calculator and not do it by hand. So 650,000 times 1.09 to the there's power of 40. And let's see if I can read this. There's 20 so 20,416,123 and 4 cents. So this was the average annual salary. So we're saying the average salary is $20.4 million. If a patient takes a 250 milligram dose of an antibiotic, the function a of t equals 250 times 0.58 to the t approximates the amount of medication in milligrams left in the patient's bloodstream t hours after it was taken. So let's use the function to determine the amount of medication in the patient's bloodstream 10 hours after taking the dose. So basically we want to replace t with 10. And that'll be 250 times 0.58 to the 10th. So again, pull out the calculator. 250 times 0.58 to the power of 10. And up with about 1.077 milligrams. So they took 250 milligram dose, and after 10 hours, there's still 1 milligram left.